Hi guys, today's lesson is over system of equations, and with this lesson today we are using what's called the equal values method, all right? And so if you ask yourself, why am I using this method, we're going to find the point of intersection with this method or a solution to a system of equations, all right? Also, why you're going to use this method is you can use this method so you don't have to graph, all right? So you might say this statement to yourself, I can use this method so I don't have to graph. Also, you can use this method with word problems there if they're asking when people might be the same or when a situation might be the same, all right? And when should I use this method? When both equations are solved for the same variable. For instance, if we look right here, here are our examples. Both in example A and B, they're solved for a variable. In A, they're solved for y, both equations here, and in B, they're solved for x. Now, our job is going to be to find the point of intersection for these two equations here, all right? Here are the steps that you're going to take. Step one, you're going to set your expressions equal to each other. So it's going to be really important that you write these steps down because in a little bit you're not going to see these. But this is what we're going to say here for our steps. Our second step is we're going to solve for the variable that you see. And again, we're going to go over an example here in a little bit. And the third step here is once you have solved for one variable, substitute your answer into one of the original equations and solve for the other variable. Again, just important that you have this written down and off to the side here when we go and we practice. And then finally, fourth one here, check your solution. All right? All right, let's go over the first example that was on your paper here. And that was your systems of equations here. You had two equations. Y equals negative 2x plus 5 and y equals x minus 1. Now, if I go back and look at my steps, it says set your expressions equal to each other. Right here, I notice that both of these have y equals. That is a big hint that I need to use the equal values method. I'm going to set the expressions equal to each other. So in other words, this. I know that y equals negative 2x plus 5, but I also know that y equals x minus 1. So I can just substitute in x minus 1 for my y, okay? And watch how I'm going to do that. I'm just going to substitute that in and set them equal to each other. Again, equal values method. I substituted in x minus 1 for y because that's what y equals there. Now ask yourself the question, what variable are you solving for right now? What letter are you solving for? And guys, this is nothing different than what you've been doing the entire year. Now just solve for x. Okay, so I'm going to go through this pretty fast. So now I would add 2x to both sides. Again, I'm just trying to get x all alone. I'm just solving for x, the normal steps there. All right, and so now when I add 2x to both sides, I have 3x minus 1 equals 5. Again, I'm trying to get x alone on one side here. And so I'm going to add 1 now to both sides because I'm in the process of getting x all alone. And so now I have 3x equals 6. 3x equals 6. It's really important here at this point when you get down here now, and again, I'll go ahead and put the equal sign here so you know. 3x equals 6. And now what does x equal? Well, when I divide by 3 on both sides, x equals 2. All right? Be thinking to yourself what major mistake people might make, and we'll talk about this here in class, but it's at this point, but I won't tell you exactly what the mistake is. All right. Once I've solved for x, it's really important now that I solve for the other variable here. So all I have to do now is once I have x, or whatever variable you solve for, you need to plug it back into one of the original equations and solve for y. Remember, we're trying to find the point of intersection here. All right? So I'm going to substitute 2 in for x. It does not matter which equation. In this case here, I'm going to substitute in for y equals x minus 1. All right? And I'm just going to substitute in 2 for x here. I'm just going to replace x with 2. And so now that I've done that there, I have y equals 2 minus 1. And I know that 2 minus 1 is 1. A good way to check yourself is to plug 2 back in for x in the other equation here. See if you get 1. If you get 1, then you are on the right track there to checking over that your work is correct. So again, this is a step that you don't have to take, but you could take there to check over your answer. So again, I'm just going to replace 2 with x here, and I see that y equals negative 2 times 2 plus 5. And negative 2 times 2 is negative 4, and negative 4 plus 5 then is 1. All right, so then I'm just going to finish here with a statement that says the point of intersection is the point there, 2, 1. Again, x comes first, and then y. I'm just going to write that as an ordered pair, all right? And so that is my solution there to my systems of equations. That is the point of intersection, all right? All right, what I'd like you to do now is this. Would you go ahead here, and I'm going to give you another example to practice, but I want you to write this one down here, and I want you to practice this one on your own. So write these 2 equations down, 2 expressions down, and I want you to go ahead now and solve. I want you to solve this, and then I'll go over this with you. So go ahead and hit pause and solve. All right, moving on here. In this case right now, I see that I have x equals. Just be aware of that. It might be in y equals, x equals. The letter might change there. The variable might change. But the point is that I see both of these equations are solved for a variable. So I've got to think to myself, equal values method. I'm just going to set these 2 expressions here equal to each other and solve for a variable. So I replaced x with negative 4y plus 2, because that's what x is here in my second expression, or the expression that I'm pointing to right here, equation, excuse me. So now I see here I have negative 3y equals negative 4y plus 2. So the variable it looks like I'm going to solve for right now is y, okay? And so again, I'm just going to go ahead and solve for y, I'm going to add 4y on the right. That means I have to add 4y on the left, okay? And I'm just going to go through again the normal process of trying to get the variable alone. And so I see now I have 1y equals 2. And so now I've gotten y alone. There's only one y there. So now y equals 2. Just remember now, once I get it to y equals 2, all right, I've got to solve now for x. I solved for y. Now I have to solve for x. So again, I can plug my 2 in for either equation there, and solve for that. I'm just going to plug it in here for x equals negative 3y. I'm going to plug in 2 for y here. So once I do that, I see then that x equals negative 3 times 2, which is negative 6. Okay, so x equals negative 6. Just to be sure, I'll just go ahead and plug y in for the other equation here. So x equals negative 4y plus 2. And so now I'm just going to go ahead and plug in 2 for y. Remember to put parentheses around the number that you're substituting in for so you know what order of operations you need to go through. So now I have negative 4 times 2, which is negative 8. And negative 8 plus 2 is negative 6. All right, so again, I just did that step there to check over. And so now there, I see that the point of intersection is the point negative 6, 2, okay? That is where these 2 lines would cross. That would be the point of intersection, and that's why you're doing that. All right, please come to class with any questions you might have. And thanks again for watching this, and make sure you get things written down. Thanks, guys.